Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/42 for the session October November 24. Let's solve question number 5, which says two particles P and Q of masses 2 mkg and mkg respectively are held at rest in the same vertical line. The heights of P and Q above horizontal ground are 1 meter and 2 meter respectively. P is projected vertically upwards with speed 2 meter per second. At the same instant, Q is released from rest. Find the speed of each particle immediately before they collide. Well, here the concept is the collision. We should not deviate from the concept of collision, that whenever two particles collide each other, then they must collide at the same height from the ground and at the same moment of time. So the time instant will be exactly same for the both of the particles. At the same time, their height from the ground must be exactly same. So these are the two concepts. Considering these two concepts, let us start the solution. First, we have told that as the particles have collided with each other, their height from the ground must be exactly same. So let us find the height of the particle A before it collides. So we can write as SP. That means displacement or height from the ground is exactly same. SP is equal to UT plus half AT square. Well, then initial velocity of particle P was 2 meter per second. This is 2 meter per second was the initial velocity of P. So it is going to be 2t plus, it cannot be plus because look at this, the particle was thrown upward whereas the acceleration due to gravity is acting downward, so it is going to be negative. The direction of the particle, motion of the particle and acceleration due to gravity is opposite to each other, that's why it should be negative symbol. Half of 10 and t square. So finally it has become 2t minus 5t square. Well, this is the displacement or height of the particle P from the ground. Now we are going to find the height of the particle P when it collides from the ground. So SQ is equal to the same concept, UT plus half a t square. Well, initial velocity of t, look at this, if we observe the question, it says q is released from rest, so initial velocity of q will be 0. And plus, whether it should be plus or minus, look at this, it depends on the reference frame. Our reference frame is actually, for q, reference frame is the height. Already it was 2 meter above the ground, that's why from the ground, it is not the ground actually, we are considering the 1 meter height above 2 meter from the ground is the reference frame, so it will be positive because the particle was moving downward. At the same time, the acceleration due to gravity was also acting downward, so direction of the motion as well as acceleration is same, velocity and acceleration is same, that's why it will be positive. So half into acceleration due to gravity is 10 t square. So finally it is going to be 5 t square. Now you may raise a question that whether it can be negative or not. Yes, if you consider the ground as the reference frame, then it will be negative. In that case, it will be minus 5t square. But we have supposed the height from the ground, it was already 2 meter high, above 2 meters. So that place is the ground. reference frame for this one. Well, so these are the two displacement we have obtained. Now we know that height, they have height must be same when two particles collide with each other. So considering this, we are going to write, let us see, first of all SP. We have learnt that the particles must be at the same height from the ground when they collide with each other, SQ. Now let's see whether the height is exactly same. SP and SQ, this is actually displacement, not height. Now whether the displacement and height should be same, our concept is height should be same. Let us see what about what is written about P. Look at this, P is already 1 meter above the horizontal ground. Okay, so we will have to, and it has been through vertical, it was projected vertically upward, so it's already 1 meter up. So from the ground, it's, we will have to add up 1 meter. Now height of the q from the ground, height of the particle q, what is written about q? Look at this, q was 2 meter above the ground. But if we read the question carefully, we will find Q was moving downward. Q was moving downward. That's why the final height must be less than 2 meters. It was above, if we consider Q is over here, okay? Q is over here from this ground, and Q was moving downward, okay? Here, suppose it is 2 meter, not here, let it be over, this is q, okay, q, this is particle q which is moving downward, and this is the ground. Okay, now look at this, as we are considering the height, so definitely the height will be less than the 2 meter, because total height is 2 meter from the ground. Now he has traveled up to this. So this is definitely less than, this height must be less than 2 meter. So for Q actually the height will be 2 meter minus the traveled distance. So for Q it is not to be added. For Q it is to be subtracted from 2, because Q was moving downward. 2 minus SQ, because our concept is height of each of the ground, each of the particles from the ground will be same. So as ground is our reference frame, P was already 1 meter above and it was projected vertically upward, so it will be 1 meter will be added to the distance it traveled. But for Q was moving downward from the total height. As total height is 2 meters, definitely it will travel some of the distances which should be reduced, which should be subtracted from total height. Total height from the ground was 2 meters. That's why we have subtracted the distance traveled by particle q from total height. After that, if we substitute the values for SP, it has traveled this distance, P has traveled this displacement, it is 2t minus 5t square. On the right side it is 2 minus SQ was 5t square. Sorry, on the left side we skipped something, so let that be written. We have skipped this one, so on the left side there should be 1 plus 1. On the right side 2 minus SQ was 5t square. Now from both sides, if we dissolve the 5t square, there will be, what will remain there, 2t is equal to 2t is equal to 2 minus 1 is 1. Hence our t is half second. That means after half second, each of the particles collide with each other. Now they have told us to find the velocity of each of the particle immediately before they collide. Okay, as we have come to know, so easily we can find the velocity of each of them, and for that Schubert formula should be applied. You know, the formula is first Vp. Okay, let me change the ink. It is Vp. So Vp is equal to, what is the Schubert formula? U plus AT. Then Vp is equal to, initial velocity of P was 2 meter per second, 2, and acceleration due to gravity is acting downward, whereas particle was projected upward, so it is going to be 2 minus acceleration due to gravity is 10, and t, we have come to know that after half second they collided with each other, so it is half. Hence final velocity, I mean the velocity of particle p before it collides with particle q is 2 minus 5, that means negative 3 meter per second. So this is the velocity of particle p. Then for particle q is equal to u plus 80, the same concept, and initial velocity of p was 0, I mean q was 0, and acceleration due to gravity was 10 plus 10, and after half second they collided with each other, so it is half. That is, it is going to be 5 meter per second. Now we will have to write the velocity. Vp is equal to, they didn't tell us to write the velocity. Remember, if we go back to the question, we will see that they have told us to find the speed. Speed is a scalar term, so it should not contain any negative symbol, but direction can be shown. So we will have to, if we write the speed of each of the particle, speed of p, we can write here speed of p, speed of particle p is equal to 3 meter per second. We cannot use the direction in case of speed, so 3 meter per second. But what is the direction? Direction, it is moving downward because it was negative. Then speed of q, of speed of q was 5 meter per second, 5 meter per second, and we should not forget that q was released from rest downward, so the velocity of q was definitely downward. That means direction of both of the particles were same, that means downward direction. So that's all about the question, all about the solution to question, first part of this question. Let's move on to the immediate next part. The next part says, next part is on the next page. It says, it is given that immediately after the collision, the downward speed of q is 3.5 meter per second, downward speed. Find the speed of p at the instant that it reaches the ground. Since the question asked for speed of p, okay, it is all about p. Now for p, if we want to find the speed, we should know the velocity just after collision. And from the previous part, we have found the velocity of each of the particles just before the collision. So if we find the velocity of each of the particles just after collision, we know the velocity can be obtained, velocity of two particles before and after collision can be obtained applying the concept of conservation of momentum. So we are going to apply the conservation of momentum concept, which is mp into initial velocity of p plus mq uq, initial velocity of q, equal to mass of particle p into final velocity, that means velocity after collision of p plus mass of particle q into velocity after the collision of q. Well, then mass of particle a p is, let us go back to the previous page. Mass of particle p was 2m. Here it is written 2m as well as m. Okay, and initial velocity before collision we have got that the velocities were 3 meter per second, 5 meter per second, and direction is same. Look at this. Yes, we should not get confused. Both of the particles are moving downward, so their direction is exactly same. This is the direction. Both of them were coming downward, so direction is same. And initial velocity, I mean the velocity before collision, the velocity of particle p before collision was 3 meter per second, whereas the velocity of q before collision was 5, 3 and 5. Let us substitute these values. So it is going to be, mass of particle p was 2m into initial velocity of p was 3 meter per second, 3, plus velocity, I mean mass of particle q was m kilo, and initial velocity of q was nothing but, sorry, it was not 0, it was 5 meter per second. And as both of the particles were moving to the same direction, so symbol in front of them will be the same. Well, then mass of particle p is 2m into, in final velocity, I mean velocity after collision is to be obtained, vp, and direction must be same because after collision both of them were moving downward, so direction was same. Mass of particle q was m, and the velocity of particle q after collision is given as 3 meter per second. This is also moving downward, so it is 3.5, 3.5. If we simplify, we will get, yes, let us do the simplification. So 6m plus 5m, 11m, and from 11 if we subtract 3.5, so directly we can write 11 minus 3.5m is equal to 7.5m, and on the right side it is going to be 2m vp. Hence our vp is going to be, that means velocity of particle p after collision is v is equal to, m can be dissolved. If we divide 7.5 by 2, it is going to be 3.75 meter per second, and direction must be negative, it is coming downward. Well, we have got the final velocity of v. It is not final actually. When it was reaching the ground, it will be supposed to be initial velocity. Well, now as they have told us to find the speed when it reaches the ground, so for speed we will apply the Schubert formula. For Schubert formula, we should know how much was the distance traveled by p. Okay, that means before it reaches the ground. So sp is equal to, we know the total distance traveled by, I mean the distance or height from ground until the particle p started coming down after collision. So just the height when p collides with q is sp is equal to, we should not forget that 1 plus, let us see what was it. It was, look at this, it's all about p. P was this is the displacement That means SP plus 1 means this one. We can pick up from here. This was the height of particle P from the ground. So 2t minus 5t square plus 1. That means 1 plus 2t plus 2t minus 5t square. And we have already found in the previous question that the value of t was half. That means after half second they collided with each other. Minus 5 into half square means 1 over 4. So if we simplify, it is going to be 1 plus 1 2. From 2, if we divide 5 by 4, it is 1.25. So it is going to be 0.75. From 2, if we subtract 1.25, it is going to be 0.75. So 0.75 is the height. 0.75 meter is the height from the ground. Now we can easily find the final velocity, and for finding final velocity, we apply the concept of Schubert formula. That means v square is equal to u square plus 2as. Okay, so v square is equal to final velocity v square. V square is equal to vp square is equal to u square, or we can avoid this square, or let it be u square plus 2as, u square plus 2as. So initial velocity we have already obtained when after the collision b was moving at a speed of 3.75. So 3.75, let us use the square root symbol. Square root or Vp is equal to square root over u square plus 2s. So u square, u was 3.75, 3.75 square plus 2, acceleration due to gravity was 10, and displacement has already been obtained. We have got the displacement as 0.75 meter. Hence our velocity of particle P when it reaches the ground, it is going to be square root over 3.75 square. Let us calculate this. Square root over 3.75. Significant figures, it is 5.39. 5.39. 5.39 meter per second. It is not actually velocity, it is speed, and it is coming downward. Actually when it reaches ground means definitely direction is downward. So we should not forget that this is the answer, and this showing the direction is not necessary at all, just magnitude is sufficient for us to be shown. So I think you have understood what I have told. Let me erase this. They have told us to find the speed. Look at this. Here it is written that find the speed, not direction, only the magnitude. Speed is, we have found 5.39 meter per second, and direction is downward because it was coming downward. That's all about the solution to question number 5 of this paper. Let me show you the previous page. Yes, this one was whole of the first page. I mean, solution to the first part of this question. So thank you all for watching the video. May Allah bless us all with beneficial knowledge. Fi amanillah.